Hello, everyone. We'll start with the session shortly. We'll start the session within 10 minutes. Till then, you can check our YouTube channel. I'll be sharing the link of the YouTube channel in the chat box. We have all the recorded sessions of the previous data hours in the session in the YouTube channel, and also you can find this video, the video to this session, within a few days on the YouTube channel as well. Hello, everyone. Welcome to another session of Data series. We'll start within 5 minutes. Till then, let's get to know each other. We have put up a poll which contains two questions about your location and experience level. Kindly answer the questions in the poll. Hello.
Hello.
Hello. Hello.
Hello.
Hi, Subhrajit. Hi. Hi, Subhrajit. Can you hear me?
Yeah, I can hear you. Can you hear me?
Okay. Yeah. Okay,
Okay,
so we'll be starting the session now.
sure.
Okay,
Okay, let me share my screen.
just a minute. Let me introduce you and then we can start.
Sure, sure.
Okay. Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here and with you this evening for a session full of action-packed learning. I am Shivansh Kaushal, part of the data science team at Analytics Vidhya, and I'll be the moderator for this session. For those who have joined us for the first time, a brief introduction to the Data Hour sessions. The Data Hour is a series of webinars conducted by Analytics Vidya and led by top industry experts. It is a fun way to understand the concept of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is Nirvana State of MLOps. In this session, Subhrajit Mohanty will take you through the third level of maturity in MLOps practices, which is Nirvana State of Machine Learning Operations. Join us to learn how to solve an end-to-end use case with a feature store and achieve the highest level of automation in MLOps as suggested by Google. I hope you are excited to attend the data hour with us. Before we kick things off and I hand it over to our speaker, a quick recap to the housekeeping items. We are recording the sessions and we'll make the recording available in a few days on our YouTube channel. Please use the Q&A section for asking any questions you might have during the sessions, and we'll do our best to answer them as the data hour progresses or towards the end. Also, we will share a poll about the feedback towards the end of the session, which I request all of you to kindly fill. Now on to our speaker. In this session of Data Hour, we have Mr. Subhrajit Mohanty with us. Subhrajit heads the technical team at Katonic and leads the development of the platform and its capabilities. He has had a long stint in the IT industry, working across various multinational organizations such as General Electric, Infosys, Grant Thornton, etc. In his past roles, he has donned multiple hats and led teams across the software engineering, data science, and big data and DevOps domain. Over to you, Mr. Subhrajit. The virtual stage is all yours.
Thanks for the introduction. Uh, Welcome everybody. So let me share my screen. Let me know if you can able to. Is it visible?
Yeah, perfect.
Okay. So you can see my slides, right?
Yeah.
Okay. Uh, so welcome everybody to today's session to advanced MLOps, which is called Nirvana State of MLOps. So this is me, and the use case and everything I'm going to explain in following slides. So the goal of this end-to-end demo, like you have to log into a platform. So the details has been shared with you already. If it is not, then we will share it again. So there are a couple of things which you need to do. You need to sign up to Katonic platform, and you can start working on the use cases. So these are the features which we'll cover end-to-end demo. So we'll see how can we create a workspace. We'll see how can we integrate with Git, then file manager, then do experimentation, model registry, how we can convert the notebooks into pipelines, then the automated pipeline deployment panel, then model deployment, inference pipelines, model monitoring, and app deployment. So there are many more things we need to cover. So this is the problem statement. So let me explain to you. what exactly the problem statement is. The goal of this project is to build a machine learning model that can predict if a person will uh, be default based on the information which is provided. That might be their personal information or maybe the other information, right, which bank tracks about a user. And the model is intended to be used as a reference tool for the client and its financial institution to help make decisions on issuing loans so that the risk can be lowered and profit can be maximized. So this is the use case. So use case, you can get a lot of use case in Google, right? You can search and you can get it. But what I'm trying to explain about the process, right? And what are the different processes which we could follow to scale these kind of use cases in real world. So let's get started with the AI model lifecycle. Of course, if you have already attended DataHour session from Katonic, then you might have aware of this lifecycle. I'll just take 2 minutes to explain about the base lifecycle. Then I could explain how can this lifecycle can be converted using the feature store and why feature store is necessary and how the use case can be converted from a simple one to a scalable one by using that. So just think as an organization where you want to build some use cases, right? And to build those use cases, you need some data. So you can consider as an offline data or historical data. And you hire few data scientists, you want to build this use case. That's why you are going to give them certain data to see how and what kind of information they could get. So that is the process of experimentation, because data scientists are called scientists for a reason, right? Because they do a lot of experimentation. Out of those experimentation, they conclude on certain patterns, or you can say certain things from the data that could help on the prediction capabilities for your organization. And during this process, you definitely need to track those. That's why we have automatically track mechanism where you can track them. Now, the next portion of is if you agree on, you can say if you feel that the model is good, then you register those models, right? Using model registry. And of course, code versioning. Then you have the training pipeline, which is automatically convert those experimentation to a scalable pipeline. And then you come into deployment of the model, right? That is where you have 3 stages of deployment, which Katonic provides. One stage is either you can convert those models into model APIs, where your application users can consume that. It might be your mobile application or web applications, or even chatbots, right? You can do that. The second way to consume is building web apps using the product, right? And web apps are like most popular nowadays to convey those information, because it's very difficult to convey business users what data scientist capability is, right? So that's why you need some kind of web apps to explain them that these are the things which we could do, so that it will be visible to them, right? That's why web apps are very crucial. And the third way is BI tool, of course. Like, why BI tool is necessary? Because there might be cases where your BI tool needs your prediction data, and you need to continuously put into their servers, and your data is automatically updated in the server, right? So that's where BI tool is really very crucial. Now, the next thing is deployment model is very good, right? But at the same time, you need to monitor those models, because at some point of time, you might not know, but your model is deteriorating, and you should track those things, right? That's why the monitoring capability also integrated. And once you deploy that model and monitor that model, if you feel that model is not performing good, you can re-trigger the pipeline and recreate your model and re-register model, even redeploy your model. So all these things can be automated. Okay, now this is version 1, right? Now we are talking about how can we scale this and what are the issues on this particular life cycle, right? So let's discuss about the issues, right? The first complexity is it's good that you have it's good that you have automation pipeline, but at the same time, if you are maintaining multiple pipelines, right? Because it's easy to maintain one single automation pipeline, but if in an organization you have a lot of pipelines, right? And it's very difficult to manage them. At the same time, there might be not reusability is happening, right? That is where we need to focus, because reusability is the key over here to save time and consume. And because if we are not reusing those existing elements, then it might consume a lot of resources in terms of your cloud resources or your infra or whatever, right? It may consume. So that's why we need to do that. And this is where the next level of MLOps is coming, where suppose let's talk about feature engineering, right? Now, during this feature engineering techniques, what is happening, right? Normally, what happens when you do feature engineering, when the model is getting prepared to build a model. Before that, the process is called feature engineering. I think all of us know about that. But in an organization for a particular use case or particular client, if you are building feature engineering, there might be a common features which is required to use, and we are not utilizing them. Rather than we are still creating a lot of different automation pipelines, and that is where the problem is. There is no reuse of features, right? And at the same time, if we talk about the predictions, right, the inference, and this feature, this training feature has to be equivalent to inference feature. Why? Because when an ML model is trained on preprocessed data, it is necessary to carry out those identical steps on incoming prediction request. And this is because we need to provide the model data with the same characteristic as the data it was trained on. If we don't do that, we'll get a skew between training and serving. And that is what it is happening, because this has to be equivalent, and that is where training serving skew is happening, right? Now, let's discuss what are the solutions for that, right? Let's talk about let's speak about few solutions. So we actually looking at challenges on feature engineering. Now let's discuss the solution. Like most of the time spent by data scientists goes into wrangling data, more specifically in feature engineering, which is transforming raw data into high quality input signals from ML models. But this process often actually takes, it's a complicated process, right? It takes a lot of time and a lot of effort, right? So this is one of the way we could tackle this kind of issue. The way is called processing within the model, because the pre-processing has to happen within the model. And this is the simplest option to incorporate the pre-processing step within the model function itself. Let's give an example. Like Keras provides out of the box pre-processing layer. This way, when the model is saved, the pre-processing steps will also automatically be part of the model. So that this is one. The advantage of this method is its simplicity, and no extra infrastructure is required. Pre-processing code is carried along with the model. So if you need to deploy the model on the edge or on cloud, or there is nothing special you have to do, the same model format contains all the necessary information. But the drawback to this approach is that pre-processing steps will be wastefully repeated on each iteration for the training data set. And the more expensive the computation, the more these adds up, right? And the another drawback I would say is you have to implement pre-processing code in the same framework as the ML model, and this is a big problem, right? Because if the model is written using PyTorch, the pre-processing also has to be done using PyTorch. If a pre-processing code uses custom libraries, this might be difficult. So this is one of the key aspects. Now let's discuss the next one. It's called transform function, right? As I have already mentioned, the drawback with placing the pre-processing code within the model functions is that the code needs to be used, transform the raw data during each iteration. So this approach, the transform functions, can be optimized if we capture the pre-processing steps in a function and deploy that the raw data. Then the model training can be carried out the pre-processed data. So it is efficient, of course. We have to make sure to invoke that function from both the training and prediction code. Alternatively, we have to capture the pre-processed steps in a container and the container between the input of the model, which adds efficiency. But it also adds complexity. We have to make sure to save those transform function is an artifact associated with the model, that the transform function to invoke, right? So that process also is a little bit complicated. And if you feel like example, like TensorFlow provide those transform capability. But now, what is the solution? Next solution is feature store, right? and this is something different compared to the previous one. So what is a feature store? It's a top level container for your feature and their values. When you set up a feature store, user can define features and then ingest feature values from various data sources. Uh, User can search and retrieve values on the feature store. For example, you can find features and they do a batch export to get training data for ML model creation. You can also retrieve features values in real time to perform fast online predictions. It is a fully managed unified solution to share, discover, serve machine learning feature at scale across different teams within your organization. And it also helps reduce the time to build and deploy your AI model application by making it easy. One, it makes the feature usable, easy to use and avoid skewness, right? We also have feature store. So Katonic feature store is fully managed solution which manages and scales underlying infrastructure such as storage and compute resources. This solution means the data scientist can focus only on feature computation logic instead of worrying about the challenges of deployment into production. And we also have integrated within the platform, so you can use feature store independently as part of the Katonic workflows. So I'm going to show you those examples and then in the product itself. Now let's discuss about few data models and resources. So you can able to see this, right? So there are different elements, or you can say terms inside feature store. Like these elements are a little bit brilliant. It's new in the field, right? It's been 2-3 years. People are talking about feature store and all. People are talking about entities, entity type, ingestion, serving, and all these things, right? So let's discuss about few data models and resources over here. So feature store uses a time series data model to store a series of values of features. This model enables Katonic feature store to maintain feature values as change over time. So here you can see, so you can create entity types that groups and contains related feature. You can then create feature that map to feature of your source data. And so in this column, if you see, the ID column here can map with an entity type of a customer. Suppose we are talking about a customer data. So the customer you can consider, you can think as a feature store, and this ID is called entity type. And the annual income, then employment length number. So you can say experience details. You can call these as your features, right? So this way you can save the information inside a feature store. And so let's discuss about few details like what is entity type, what is entity, feature values. So let's go entity type. What is exactly entity type? It's a collection of like semantically you can say related features. You can define your own entity type based on the concept that relevant to your use case, right? Suppose you have a feature store for movie, right? You can define as a movie ID, probably that's your entity, right? Entity type. And now there is an entity type, there is an entity. So entity type is like here is ID is entity type, but each customer ID is your entity. So you have to make that difference to understand them, right? And feature is nothing but the element or the component which we use, like annual income or something like that. But feature value is annual income of a particular customer is a feature. So these are different terms which feature store is used. So you don't get confused over that, right? So let's try to digest them. So this is Katonic feature store architecture. It's very simple. We have data sources, batch processing using Spark and Pandas, then offline store. Then if you want to get your historical information about the features, you can do these get historical feature you can use for training data. Then you have a registry where you can save those information because over a period of time, if you are continuously using a feature store, writing the new features, then over a period of time, you need to track them. That's why this is very crucial. So that's why we have registries. And when you serving those features. And we also have serving mechanism where you can serve that. And while building a model, you don't need to transform your data, rather than you can get those data from the feature store and build the models. And that will save a lot of time. Even multiple data scientists can communicate to each other. They're kind of using each other's features if they are building similar kind of models, or even the use case might be different, but they are using the common data to build those features, right? So those kind of flexibilities are. Now the same AI model lifecycle I am going to explain using feature store. So this is same. You have offline data, experimentation, everything same. Now this is where the changes happen, right? It's feature store in between. The second step will be feature store. Now I am not calling the models directly within this experimentation stage. I can directly save those information in my feature store. Then I can build those models, and the rest things are already same, right? Which I have just explained. So feature store is coming over in the second phase of your model lifecycle. And if you are trying to build your models using different kind of algorithms, you just need to get that data from your feature store. So this is where the theory portion of the feature store is there. So there are specific element I want to highlight, like if you are creating feature store, you need to follow certain techniques. I'm going to show you how the code has been built, and how can you use that code to build those pipelines, and how can you use those pipelines and all. So before that, let me discuss about a few of the options which we have, and then let's go to the process. There is, so in our product, there is a component called accelerators, right? And what is this accelerator? I'll just explain about this. Let me go back to the platform. Let me click over here, accelerators. So accelerator is nothing but we are providing you the ability to play around different use cases. Not only the code which is available, but also we have deployed certain apps which you can play around those apps. So if you see this accelerator, let me, it's my internet problem probably. So let me show you few of the examples which I'll like to show. So let's go to today's example, which I'm going to show you in the demo. If I click on banking and financial services, once I click over here, I can search for that bank loan default prediction. So if I click on this particular app, I can see the details of the app, which is mentioned over here. If I want to see the code, I can click over here. I can see the code, and inside the code, I have complete explanation about the use case, the kind of data we use, and the different exploratory data analysis processes which followed. So everything you can get over here. Apart from that, if you want to launch your app, then you can just click over here and you can launch the app. And by launching the app, you can have different way to inference the data. If you have by customer ID, you can place the customer ID, because this is mapped to the particular data which is already provided. So you can map those customer ID, you can get the inference. If you have customer data, you can just fill these details. It's like real-time predictions, right? You can just fill the details and click on prediction. Then you will be getting the prediction details, like whether the customer will be default or not, right? So this is already integrated as part of the product. So if you have not already signed the Katonic free version of the platform, you can always go there into our website and you can sign it, and you can even play around these use cases. Now the next step is, okay, now spinning a workspace, right? So let's come here, workspace, and this is our workspace. And here you can see there are Jupyter Labs, there are even VS Code, even Jupyter, all these kind of workspace is visible. If you want to create a workspace, it's very simple. You can come here click on create workspace. You can put a name. You can select the workspace of your choice. Select the customized versions of images, or you can say the frameworks you can select. There are two different frameworks which we provide. It's called Katonic Studio and Base, which is Katonic in-house customized Jupyter Lab, where you can able to convert your pipeline into convert your code into pipeline very efficiently. I'm going to show you that in the demo, and you can select the resources, of course, right? What kind of resources you want for a standalone deployment. Once you do that, you here you can have your workspace. It's a connect option, stop option. You can see the logs, the backend logs. You can delete. You can able to see the maximum memory and CPU which is allocated to this particular environment. Just click connect. Once you click on connect, then you have the notebooks, right? It's a very famous Jupyter Lab notebook where you can start writing your code. So this is one of the notebook which we have. So for this particular use case, I have 4 notebooks. One is for data pre-processing. One is for ingest data into feature store. Then model training, because model training will happen after the feature store, after the data is inserted into feature store. Then of course the inference, right? So these are the 4 different steps which we have. You might have know about all this Jupyter notebook, right? And how can you use it? So what we did, we have customized a little bit, and we have integrated a Katonic deployment panel for this particular notebook. What you can do, you can just maintain your code. You just write your code. After that, once you finalize that this is my code and I'm done with that, you can come over here. You can enable this deployment panel and just do compile and run. Once you do compile and run, this automatically creates a pipeline, right? And this pipeline will be visible over here in pipeline sections. So if you see, this is a data pre-processing pipeline which is started, and it will take some time. So let me go back and show you the existing data ingestion pipeline. This is a very simple pipeline. It's loading data and ingestion data into feature store. So you can even see the logs. If you have any visualization, you can able to see. So there is no visualization for this particular data for now, but we'll get more visualization on data pre-processing. So let me go back to the data ingestion to feature store. Data pre-processing pipeline. If you see this pipeline contain loading data, exploratory analysis, and feature engineering techniques, then saving the data into feature store. So let me go back to the exploratory data analysis. If you see, there are a lot of different visualization you can able to see. So this is dynamic, right? Suppose you have an input where you are passing the data from a particular DB table, or you can say the file path. You can change the file path, and automatically the internal EDA process on new data will be automatically populated over here. So these are the different analysis which you can do over the data, and with this you can probably get to know like the behavioral changes or the kind of things which you want to build from the data, right? So this is very useful for the data scientist to analyze these things. So this is already integrated as part of this, so you can leverage this. Now once the data is loaded into feature store, then the training pipeline comes, right? And if you see the training pipeline here, I'm loading the data from feature store, then retrieval historical data, then I'm splitting the data between training and test just to validate, and I'm doing 5 different algorithms on top of it. So if you see, these are scalable pipelines, right? Why this is scalable? Because individual component is running in individual containers, and that is vertically scalable. So suppose loading data is required 4 GB of RAM to process, it automatically consume those. After the process is done, then it will release that memory, and it will try to execute the next one. So these are sequential steps which is running. At the same time, you also have the parallel steps, right? Why? Because this is also very crucial. Because if you are running 20, 30, hundreds of models, how can you leverage the scalability? So that's why we have as part of the pipeline, we can utilize this and we can run as many models we want to run it. So this is where the model training portion is happening. So now the final part is inference, right? Inference, fetching from online store, then you have the inference logs. If you see, this is a classification problem, right? So these are like 0 and 1s, which you are getting the outputs. So this is where the complete stages, right, to a particular use case, you can convert into 4 different pipelines, and each pipeline can occur at different job to complete those processes. So this is where the actual entire journey of MLOps in terms of converting into pipelines for each stage and involving on feature store, that is going to be helpful. So in between, so when you start doing it, right, you want to register those, because registry is also a very crucial point. That's why we provide the integration of ML flow as part of the experimentation, where what you can do, you can register your models as part of the pipelines. You can come over here, you can click, you can see, right, the details, the parameter, the matrices, all these things can be seen over here. And if you want to register certain models, you can filter based on certain criteria. So suppose my criteria is I'm checking for accuracy score, right? So I can just sort that out based on the accuracy, and I feel this model is performing good. I just want to register the model. I just click on registry. I can select here. I can register the model. And if you register the model, because pipeline helps you to save the data into feature store, create training pipelines, because model training is a crucial component. But at the same time, this experimentation will help you to track those conditions which you have followed to build those matrices, right, for a particular model. And that is where the model registry is quite crucial, and even version controlling of your models. And if you come over your model registry, if you click here, then you have different versions of your model. So if you see, there is one version which is tagged into production, right? But if you want to deploy a new model, which you feel that is better than the previous one, you can come over here, you can select this, you can transition to production, click on OK. If you go back, you can see this model now move into production. So with this, you can able to redeploy your model, because if you feel over a period of time, if a model is not behaving properly, you can tag into production. Then with the help of deploy, you can redeploy. If you come over here, model API, you put a name, you can select which registry you want to go for, then automatically the versions of your model will come. Then you can select the classification or regression on different types, right? Then you can come over here, you can select the resources, and you can deploy the model. So while deploying a model, you will be getting the details of the model. So this is already deployed a model where you can see this is a type of model. These are the logs which is running internally, and you can track those. You have Swagger and redoc URL. If you click, you can have the different methods which the model has, and you don't have to build anything, right? This is automatically giving you the ability to REST API endpoints, right? And the API endpoint can be visible over here. So you can have those endpoints over here. To call this model, definitely you need a token because this model cannot be called without any token, right? So that's why we have provided the expiration date with the token. If you click on generate token, you can get that token. Just copy it. You can able to call the inference, right? You can get to call the model with the prediction data, and you will be getting the predictions. And as I mentioned, because deployment is a part, but monitoring is a different part of it, right? Without monitoring, you cannot get to know like whether the model is performing good or not. That's why we have certain monitoring techniques which is integrated as part of the model. That includes real-time model latency, request counts, request rate, and whatnot. If you are starting getting calls to this particular model, the data also will be updated on this. So let me run this inference pipeline. To run again, just need to clone run, then just to start. So inference pipeline will be started, right? And once the inference pipeline will run, then automatically the data will also updated over here. So during this pipeline, right, which we talk about a lot about pipelines and how you convert these pipelines, how can you create these pipelines and all, you can even schedule these pipelines. So to schedule this, you can come over here, recurring run, create a run, can select your pipe, then select the versions of your pipe. As of now, I have 2 versions of this particular pipe. I can put a name, but then select the experimentation where it belongs to, then select recurring. Then you have periodic or cron job. If you know cron job, you can just put a script and that will give you the scheduling capabilities, right? If you want to go for periodic, you can have that. You can have a start date. You can have an end date. You can select the time from when to when you want to run and on which interval, right? So each hours, days, month, or weeks. So this scheduling capability will give you the ability to create those batch jobs which can help you to store the data into feature store, right? On a frequent, on a certain frequency, right? On certain time basis, right? So you can still do that, and at the same time you also can use this for your inferences, because inference also is the key. So if you want to get your inference each day, you can do that each month, or you can do that. And if you have certain processes where you want to move the inference data to a particular cloud store, object store, or a DB, you can do that using this batch pipelines. So that is where this will be very useful in terms of the scalability, in terms of your usability. Even you can use this pipelines for your model retraining. You don't need to schedule it, but as I showed you, right, you can also run it once. You just need to use it as a clone run, and you can clone that, and you don't need to recreate your code to build that, right? If you have already defined the code, already defined the pipeline, just use it. So this is where the model deployment part is over. Now, this is one type of consuming portion, which I mentioned about the REST API endpoints. The next one is how can we build certain apps on top of this, right? So that is where we have section called deployment apps. So if you click over here, let me show you the capabilities. If you put a name, you can select your app of your choice. Just provide you GitHub token that defines you automatically the username. And once you get that, you have 2 different accounts. One is personal and one is organization. So you might belong to certain organization, and that is where the difference of different repository might come, right? So if I have my personal account, I can get to know get the details of my repositories. But if I have organization account, then I can come over here, I can select certain organization, then I can select other repository within that organization. And in the drop down, if I select that, then automatically I can have my my different repositories. So let me select my personal accounts. So after that, I can have my revision type is at the branch or tag. So if you are following certain processes to create tags, you can still use tags. If you are maintaining your master branch as your production branch, then you can still go for your branch, and you can select the branch. You can put a file name, which file name you have given for your app, and the Python version, of course, because there are different configurational changes based on different Python versions. You can select that, and resources, of course, you can select, and the environmental variables. Suppose you have to use certain access keys or different elements which you don't want to put inside your code, rather than you want to use as an environmental variable, you can still do that. And this is one of the sample app which is deployed. Let me show you how that looks like. So this is one of the sample app which is hosted over here, and this is built using Dash app. And at the same time, the data has been used internally, and that is integrated with the prediction capability as well. So this kind of app you could build. When you deploy one app, you can have different information, right? That information includes your commit ID. Why we have given the commit ID? Because at any point of time, you can track which portion or which version of your app is deployed. In that way, you can track properly, and you can even update your app with new versions. So this is where the deployment capabilities and the information about your data science workflow and your communication between your data scientist to business user can happen. So let's discuss about where you don't need a feature store, right? Because as I mentioned, we have feature store where you can maintain your feature in a single place. Your data scientists can communicate to each other to use those features, and they can build different apps. But there are certain scenarios where you really don't need feature store, and that's why we have that ability for any kind of organization. If they really want to go for feature store, they can still use it. If they don't want feature store, they can still use the platform without feature store. So those kind of capabilities we provide. So that's why I want to highlight this point, why and in what condition you even don't need feature store. Suppose as an organization, you already have data warehouse and you are maintaining your features in a common place, right? Because I've seen that, right? People are already using data warehouse to save their features in terms of tables, in terms of their files, whatever, right? But they're saving it. And that way, in those particular scenarios, you really don't want, because you can directly get the data from there, and you can train your pipelines, right? So that is one condition. Then no time dependent features. Like if you really don't want those features which is time dependent, right? Because today I'm as a user or as a data scientist, I am writing a feature and I'm putting into my feature store. Tomorrow, there is some other guy who is trying to create similar kind of features, but he's putting that information in the same table. So those kind of things, it's if it is not required, then you really don't want a feature store in your organization. And the other part is if the collaboration between the data scientist team is not required, because if you guys are working on a different use cases and you really need to create your own features for that particular use case, then you don't need feature store. The next point is streaming is not requirement. Like, of course, if you don't have a requirement on streaming data, then you really don't want feature store. And only for batch processing, it is fine. Like if you don't have the requirement of streaming, rather than you are only focusing on batch, then we can still skip it. And your feature creation is not expensive, right? It's if it is not expensive, then you shouldn't go for it, because if feature creation process is too expensive, then the process you need to do once, and you need to save that features into a certain data warehouse or feature store, like something like that. So these are the few options, or you can say the scenarios where you don't need feature store. So now let's talk about one of the component which we have is called Explain It. It's an open source SDK where you can even download, or you can even install in your machine, and you can try it out. And what exactly it gives? It gives you the ability for your data quality management and drift detection for your training and prediction data. And these are few screenshot which is there. So I'll show you how you can use it using feature store, because that is very crucial, right? And because feature store, we are using feature store for training our model, but at the same time we can use inference and the training data and inference data. By combining both, we can have this kind of app. So let me show you that. So this is my VS Code, which is hosted in the platform. If you see, I use feature store over here and get the data. So these are few parameters which I use because the customization also there. As I mentioned, we can still use Postgres as our feature store, offline feature store, Redis as an online feature store, and these are the things which we could use. So this is the sample example where I'm showing you how can you retrieve the data, training data from feature store. So this is entity.df where I am reading the data from a CSV file. Then I'm just trying to get the information from the feature store, and I'm just trying to get few customer IDs, and this is where I'm converting that into a data frame, and this is the endpoint which is generated, and the source token, or you can say the secure token which I have created while deploying the model, and by using that, I'm creating a test file, right? And I have now a training data and test data, and what I am doing, I'm just passing into the functions where I am passing into training data and test data, and the column which is a target column, and what is the type of the target? Whether it's a categorical or numerical. All this information you can able to get while using the SDK. It's very simple. This example is included feature store, but without that also you can get it. So once you do that, you are automatically getting one endpoint over here, and the application looks like this. So here you can see the data drift that includes how we assume that these are the different statistical tests we did on top of the data, right? We have defined those parameters as well, right? There are different what I can say, there are different mechanism, or you can say the configurations which is required, or different scenarios which is required to do those tests on the data. So those has been defined over here, so you can go and check. And apart from that, you can have your you can select certain column, and you can have the distribution as well. Similarly, for the target drift, you have this. And not only that, you can also have the data quality as part of this app as well. And different correlations. And there are different techniques, right? Which you can select, and you can see the information as well. So if you have those data, then you can get this app up and running in few minutes. So with that, probably I'll like to answer a few questions. So we have only 10 minutes, yeah. So let's try to, yeah.
I'm very sorry to interrupt, but before we proceed to answer the questions, I would like to request our attendees to kindly fill in the poll about the feedback, as it helps us to conduct more such sessions. And yeah, I'll launch the poll, and Mr. Subhrajit, you can go on to answer the questions. Just a minute, I'll launch the poll, and I'll tell you to answer the questions.
Sure.
Okay, yeah, we can now move on to the question session.
Okay, so okay, so first question is feature registry and feature store are different? So these are two different terms, but it under one umbrella, I would say. So feature store is whatever I said, right? Feature store is like the superset of everything. Like the entire concept is like entity type, feature registry, everything fall under feature store. But what feature registry is, when you are working on features, you are capturing those informations, right? The information including timestamps. So suppose you are trying to log those features on a certain timestamp. At any point of time, you can go back and check what you have logged, right? And that is where you need a registry where you can do time travel. So that is where the registries come into picture, and that is very efficient for any data scientist to track them, right? Because as a data scientist, if I have created a feature, uh, suppose on a date, I can anytime I can go back and get those feature information, because there might be possibility that I might have created multiple features with the same name, or you can say same entities, right? But I can still have that capability to go back and get the data from there. So that is where the registry comes into picture. Can we convert .py to IPynb directly using this? So this in the sense, whether are you trying to say about the pipeline? That is not the way it works. So you can say whatever I showed you, the automation part of it, like converting the notebook into pipeline. That is where your notebook element, or you can say the component of Python code, is converted into a containers, separate containers. It's not a single container, of course. And that separate container running independently, irrespective of their environment, right? And that gives you the scalability, and you don't really have to worry about that. So I think this is a different way to represent this thing. No,
I'm sorry.
yeah.
Yeah, I'm sorry to interrupt. But you can see the question answering section over here. I mean, you are in the chat
Okay.
section, but question answer. Yeah, most of the
Okay.
people.
Sorry. Yeah. I think I opened the chat section. Okay, yeah.
Okay. Yeah. Sure.
Okay, first question is, hi, is there any way to automate feature engineering process? The purpose is to obtain high quality features. Of course, feature engineering process, if you define it once, just like I showed you in the pipeline, right? If you define certain processes, you can automate that, right? So let me give an example. Suppose you have defined a process where your input source is Oracle DB, and you are taking the data on a daily basis or monthly basis based on certain conditions, or might be certain filter conditions, right? You can create that inside the pipeline, and you just need to run that pipeline on every scheduled time, and automatically that takes the new data, and your new data will be converted into features and loaded into a feature store. So that process can be automated using pipeline. Does every MLOps has same process and footstep which you showed in Katonic? Is it different platform? MLOps as a concept is kind of similar, but the way it handles using different platform might be different, right? And we wanted to make it very simple for a user, so whoever comes to our platform, uh, so that it will be easy to understand the process. Even at the same time, you don't need to worry about how can you build this process, right? You can just use certain tools to convert those processes into a scalable way without knowing about a concept like Kubernetes, Dockers, and all, right? So that's what we are trying to do here. How do we know the deployment is working? Okay, so when you deploy any model, you will be getting one REST API endpoint, right? And with that, you can able to generate a token. With that token, you can able to call that model, and you are getting the inferences. So when you get that inferences, of course, you will be knowing whether that model is working or not, right? That is one way if you're trying to test it, or else we also integrate the Swagger. So inside Swagger also you could test that. So both ways can done that. Okay, so you want to see the deployed app. Let me show you that. If you see, this is a model which is deployed. I'll just copy that model over here. If you go to API endpoint, I'll just copy here. Then I'm generating a token. I'll just copy that. Just put over here. Now what I'll do, I'll just save it. Now I'm converting to a pipeline. We'll see while answering your questions. We'll see whether this model is working or not. We'll be probably able to get that endpoints details with logs here in the pipeline itself. Inference pipeline is started. So we will get to know like once the pipeline execution is done. In data conversion API deployment, with elementary data exploring, converting, Python version, solving, rolling out, implementary collaboration strategy in data documentary. I am not sure whether I could understand that question. Could you please explain it again? That would really be really helpful. In AI model, simplify the MLOps maintenance of data consolidation, loan data, data source, use cases, feature in complexity, data management, data security, encryption. Okay. As I said, right? So if you need to implement anything, right? Because we are not giving you the ability of anything which you cannot do. What we are giving you, we are giving an environment where you can customize your thing. So whatever you want to try it out using your code, you can able to convert them into a scalable pipeline and you can do that. So for the data security encryption and all these things can be handled, right? Everything can be handled because as a product, we are independent to any kind of system that stop us for solving certain problems, right? So that is something is integrated as part of this. Okay. The drift which you showed is for tabular data. We also support concept drift. How will you monitor data drift for images? Can we do distributed computing at a platform? Yes, we can have distributed computing. We support Spark, Ray, and Dask. So you can use them because our platform runs on Kubernetes, and we leverage Kubernetes capabilities to run all these jobs. And these jobs can run as a container, separate containers, right? And when we talk about containers, we can talk about actually the distribution or the scalability. So we support that. The tabular data, the monitoring portion which I showed. So we have just released that for the tabular data. We have certain roadmaps where we will include concept drift, even different element which you mentioned about the handling images and NLP data. Also, we are going to include. So you can able to see that visibility in coming months that will be integrating everything as part of that monitoring SDK, and that is open source. So happy to get some contribution from you also. Like if you want to contribute to that particular applications, then we can also do that as well.
Okay, yeah, I'm sure we have more questions, but since we're running out of time, we have to end the session here. That was a very knowledgeable session. Thanks a lot, Mr. Subhrajit. Now we're going to answer all the questions. It's already 8 p.m. So yeah, thanks a lot, Mr. Subhrajit, on the behalf of Analytics Vidhya. I would like to thank you for your time and for delivering such a wonderful session. And I'm sure our audience found it insightful, and hopefully we can conduct more such session with you in the future. I hope you guys have filled the feedback poll. If not, I request you to please fill in the poll about feedback, as it helps us to conduct more sessions. The recording to the session will be available in a few days on our YouTube channel. I have posted the link for the YouTube channel in the chat. We'll be back with another session of the DataHour tomorrow. The link is in the chat. I have posted the link for upcoming session of the Data Hour. Thank you, Mr. Subhrajit, for the session.
Yeah. Thanks everyone.
Okay, thank you, everyone. We'll be back tomorrow. Till then, take care, keep learning, and peace out.